Here we are on page 11, solutions number 17 through 24. We're expected to factor these guys. So we'll start with number 17. Looks here like we can pull out a greatest common, nope, we can't quite pull out a greatest common factor, so we're going to have to take the first times the last is a negative 64. And if we start looking at the factors, that 1 and 64, we're like, oh, wait a minute, there it is right there. So we're going to break that middle term up. That tells us that 63 came from a positive 1 and a minus 64. They add to the middle and times to that guy exactly. So we're going to break that up. 8x squared plus 1x minus 64x minus 8. That little trick turned it into 4 terms, and now we can do grouping where we put those two together and those two together. Take out an x there. We have 8x plus 1. And then take out a negative 8 there, and we get 8x plus 1. And you'll see, once we have done that, hey, look at that. We have that cute little 8x plus 1 sitting in both locations. We now have 8x plus 1, x minus 8. And if you did it the other way and switched those two around, you would get x minus 8 and 8x plus 1, same thing, no matter what. Okay, number 18. Negative 14m plus 6m squared. It looks like we can take a 2m out of both of those. Again, try the greatest common factor first, see if it works. We're going to be left with a 3m here and a minus 7. And you could have written that as negative 7 plus 3m, or taken a negative 2m out, and they are all equivalent. Number 19. Let's change colors here. Number 19. Here we have x to the 4th minus 7x squared plus 4. Now, this is one that kind of looks just normal, trinomial with leading coefficient 1, so we can factor it. It's going to have an x squared and an x squared. What times this together to positive 12 and adds together to negative 7, and we get a minus 4 and a minus 3. One of these, look at that guy, that is a subtraction between two squares. That's a difference of squares. So we could write that as x plus 2, x minus 2, and then this guy over here is a difference of a square and, well, that's the number 3. So that's not going anywhere. So we're stuck just like that. Number 20. Ooh, a big one here. Look at that guy. There are 4 terms here, so we're not going to be breaking it up or anything. We're going to try and pull out the greatest common factor first. Is there anything as a y in everything? Oh, not quite. 3's there. Well, so we're going to do grouping. Let's try to put those two together. Try to put those two together. Here we could pull out a 4 and an x. We're left with 3x plus 7y. And here we can pull out a negative number, just a negative. If you'd like to, we could write negative 1. The 1 is not necessary, but if it helps you to see what we're doing, 3x. Oh, we could pull out a, I was wrong about that. We can pull out a negative y is in both cases. And we're left with 3x plus 7y. Make sure you're okay with y. This is a plus sign. If we were to distribute this 4x back through, we'd get the first two terms. And if we distribute the negative y back through, we would get this back. And so that has to be a positive sign so that when we distribute it, we get the right thing. We now have a 3x plus 7y in both cases, so we can pull that guy out. We get 3x plus 7y times 4x minus y. And there we have it. That's number 20. Number 21. Ooh, here we have, can we pull out a greatest common factor there? I'm going to pull out a negative 3m. It looks like I could pull out a 3m squared as in everything. So that leaves us with m squared minus 3m plus 4. So we pulled out the greatest common factor. Now what's left is a trinomial with leading coefficient 1, which means it's going to break down into one of those fast ones. M. What times is to a positive 4 and adds to negative 3? Ooh, should do like a positive 4 and a negative 4 and a positive 1, but that doesn't work. Let's double check over here. We got a positive 4 and we got a 1 and a 4 and a 2 and a 2. These will have to be opposite to give us a 3, so, oh, we're done. This is the end result. Number 22. 25x squared minus 49y squared Nothing common. This has y's, that has x's. This has 5 and 5 and 7 and 7. So there's nothing common. This is a binomial and a subtraction of things that are, oh, look at that. Those are perfect squares. So this is 5x times 5x will give you 25x squared and 7y. So 5x minus 7y and 5x plus 7y. There's our conjugates to give us a difference of squares. Number 23. X squared minus 10x plus 9. Ooh. Factors of 9 are 1 and 9, 3 and 3. Positive 1 and... if they're both negative, does that times to a positive 9 and add to a negative 10? It does indeed. So those are 2. X minus 1, x minus 9. 24. Ooh, a little bit turning around necessary. This is our one with our highest degree or power, so we're going to have to do that one out in front. I think we can take out a 7 and a z. 7z, and we're left with z squared. Again, I took it out of that guy first, and then that one, so that'll give us a plus 3z, and then a plus 2. What's left is a trinomial with leading coefficient 1, so it should be one of those fast ones, unless we get tricked like in number 21 where it doesn't come out nice. This is 7z. Factors of 2 are 2 and 1. Yep, they add up to 3. So z plus 2, z plus 1. And there's number 24.